Welcome to the lesson on perimeter and area. In this particular lesson, we will take a look at some of the comparisons and changes of perimeter and area as shapes change. Now, perimeter is the distance around a figure, and area is the amount of space a figure takes up. And we got to think that as a two-dimensional figure changes, so does its perimeter and area. But it's how those perimeters and areas change is what make things interesting. Let's imagine a table, okay, where four people are sitting, one person on each side. So that table is 1 square unit, 4 people. If you have another table, you can have another 4 people. Now, what if all those people are in a group together and they want to group their tables together and all sit together? If one person is still limited per side, well, 2 people get left out in this case. So bunching together those 2 tables does not mean that all 8 people can comfortably sit at that group of tables. So let's think about it. One table is 1 square unit with 4 people sitting there. 2 tables is 2 square units and only seats 6 when grouped together. So what will happen with 3 tables? So let's say we bunch together 3 tables. That's going to be 3 square units and only 8 people can sit there. So 3 tables, 3 square units, and 8 people can sit comfortably. Well, what happens if we bunch together 4 tables? So let's do so. I put together 4 tables, 4 square units, and as we can have already predicted, we're going to get 10 people that can sit at a table. But if we rearrange those tables differently, those 4 tables in a different way, we'll actually only be able to seat 8 people again because 2 people will get left out. So there's 2 possibilities for 4 tables, both 4 square units, but this time we only will seat 8 people. Now, this particular scenario leads us to think about the problem of a farmer's fence. Let's say a farmer wants to build an enclosure and has 160 feet of fencing to do so. And he wants to create the biggest possible enclosure for his animals or for farming, for whatever the case may be. He wants the biggest possible area with just 160 feet of fence. So he has some possibilities to make his rectangles. Let's say he makes a rectangle with sides 60 and 20. So it's 60 on 2 sides, 20 on 2 sides. That's 160 feet of fence. 60 times 20 will give me 1,200 square feet. That's pretty big. But are there other possibilities? Let's say he makes a different size rectangle and uses 50 and 30, so the numbers are a little bit closer together. So it adds up to 160. 50 times 30 will give me 1,500 square feet. 300 more square feet of space, and the number of fence hasn't changed. So lastly, I'm going to make a square with all the sides 40, of course. 160 feet of fencing went into it, and I get 1,600 square feet. The biggest possible area came from a square of 40 sizes. So it also makes you think about size changes and how perimeter and area can change, or in some cases, can they not change? Let's think about a rectangle that has a length and a width. My perimeter is going to be the 2 lengths plus 2 widths. So to shorten that up, I have 2L plus 2W will be the perimeter of any rectangle. Area of a rectangle is a much simpler length times width, so it's really LW. Now, let's say we double the length and double the width of this rectangle to make a larger shape. So imagine I'm doubling it. I'm going to have 2 L's up here, 2 W's, 2 L's along the bottom, and then 2 W's along the remaining side. So since I have to add everything for perimeter, I know that I'm going to have 4 total lengths plus 4 total W's. So my perimeter doubled. Instead of 2L plus 2W, I have 4L plus 4W. Now my area, however, did something a little bit different. Since I have 2 L's and I have 2 W's, for area, I have to say I'm going to multiply 2 L's by 2 W's, which is my new length and my new width, which then will give me 4LW. So even though my perimeter doubled, my area quadrupled. LW turned into 4LW. And this can best be illustrated with the pizza problem. Now, with this problem, we imagine that we buy a very small pizza, perhaps a personal pan pizza, that has a diameter of 6 inches. Pizzas are measured in diameter. So if the diameter is 6 inches, the radius is 3, and the area of my pizza is going to be 9 pi square inches. We don't have to find the exact. Just know that it's 9 pi. Now, if I'm going to double the diameter of this pizza, and let's say get a large pizza, my diameter is going to go from 6 to 12. Now what's going to happen to the area? My radius is 6, so the area of my new, much larger pizza with a double diameter will be 36 pi. Now it's easy to see the relationship between 9 and 36 is times by 4. So even though I doubled the diameter of my pizza, my area was once again quadrupled.